Hello scholars, welcome back to the channel. We are introducing the topic of geometry at the grade 4 level. So what we're going to be doing now is just look at some basic geometric terms that we must understand before we move forward. So I have written the definitions on the board. I'm just going to go through them, read them, and explain as we go along. So these are the basic geometric terms. A point. A point is a single position in space. So we would say a dot. That's another name a common name that we use for the point. A dot, a period, a full stop. Those are points. So it's a position in space. Space meaning a flat plane, a plane surface. So a point is a single position on a plane surface, right? And here we have a point. Like I said, it's a dot. Can you see it? So this is the point, the full stop. That's a point. Now we can name the point. So we can say this is point A, or point B, point C, whatever. We use a capital letter to indicate the name of the point. A line segment. A line segment is the shortest distance between 2 points. A line segment has 2 endpoints. So here we have a line segment. Here is an endpoint and another endpoint. Let's name them. So let's call this point A. So this line segment is going from point A to point B. 2 endpoints, right? From point A to point B. A ray. A ray has 1 endpoint and continues towards infinity in the opposite direction. So this is a ray heading towards the right. This is the endpoint. This indicates, the arrow indicates that it continues toward infinity. So you know infinity has no end. So it starts here and continues toward the right. This ray has the endpoint here and continues towards the left. So it can be drawn in any direction. Any direction. So the basic idea then is that the ray has 1 endpoint, and at the other end, for want of a better word, at the other point, it continues towards infinity. A line. A line has no endpoints and continues towards infinity in both directions. So usually when we're talking, just casually speaking, we would draw something like that and we say that's a line, right? But in strict mathematical terms, the line should have 2 arrowheads, 1 at either end, to indicate that there is actually no endpoint. It continues towards infinity in both directions, in strict mathematical terms. You can get away with just drawing a straight line and calling it a line. You can get away with that, but if you want to be correct in terms of geometry, the line should have arrows at either end indicating that it continues towards infinity in both directions. Now an angle. An angle is formed where 2 line segments meet. So wherever we have 2 line segments meeting, no matter in which direction they're coming from, how they meet, once they meet, they create an angle between them. As a matter of fact, once they meet, they automatically create 2 angles. An interior angle and an exterior angle. So here we have the 2 line segments meeting. An angle is created in here. This symbol is a Greek symbol, we call it theta, and we often use theta in mathematics to represent the unknown angle. It's not an O, it looks like an O, but it's really more like that, right? It's called theta. So wherever you see theta, that usually indicates there's an angle. They're talking about an angle. So once we have these two line segments touching each other, it creates an angle in here. But it also creates an angle out here. It's a big angle, and we'll get to that in the next video, types of angles that are formed when line segments meet each other. That's the next video. It's a big angle, it doesn't look like the typical angle when we talk about angle, but it is an angle. And we call that the exterior angle, or the outside angle. Remember, exterior means on the outside. Interior means on the inside. So usually the smaller angle we refer to as the interior angle, usually, not all the time, and the one that is formed on the outside of the diagram, we call that the exterior angle. So once you have two line segments meeting, automatically two angles, at least two angles are created. The interior angle and the exterior angle. So the angle is the space, the degree of space that is occupied within that area where the two line segments meet. And we measure angles in degrees. So let's write that. So angles are measured in degrees. And the symbol for degrees is just a tiny little circle at the top. So for example, if we say 56 degrees, we'll put 56 and a little circle at the top to indicate that the space within here is 56 degrees, and we use a protractor. The instrument that we use to measure the angle is called a protractor. Now let's look at types of lines, because we need to know this as before we proceed. How do lines interact with other lines? We just saw that lines can meet each other, line segments can meet each other, and commonly we speak of lines meeting each other. So you can get away with saying these things, but in the strict geometric terms, just remember, if we're talking about a line in strict geometric terms, we mean it must have the two arrows at either end. But you can get away with calling these lines, right? And we're actually going to be doing that. So this is a vertical line. It runs straight down, up to down, or down to up, whichever way you want to say. Straight down. So like if you take your hand and you do like this and try and keep it as straight as possible. That's a vertical line. Vertical line. The horizontal line is straight across. Like you take your hand and try and get it straight across. That's the horizontal line. The oblique line, or we would say slant or diagonal, or we could also say slope, incline. All these words indicate the oblique line. It can be a single oblique line, slant in any direction, at any angle, or it can be two oblique lines. They can be outside of a shape or inside the shape. So if we have, let's say, a rectangle, and we connect the vertices like that, so we'll say those are the diagonals of the rectangle. Two oblique lines connecting the vertices. the diagonal. So anytime you see oblique, diagonal, slant, slope, incline, this is what we're talking about. It is at an angle, can be a steep angle or a gentle angle, right? Now parallel lines keep the same distance apart, they never meet. So if you take your hands and do like this, right, here your hands are parallel to each other, the same space between them all the time, they never meet. If they were to cross like this, then they would be oblique, which we just talked about, right? And we said that's vertical, that's horizontal, so they can be parallel and vertical. So these two hands are vertical and parallel, same distance apart between them, they never meet. And this is horizontal and parallel. And this is oblique and parallel, right? Oblique and parallel. Slant and parallel. So here we have them. Horizontal and parallel. Vertical and parallel. Oblique and parallel. The important thing for them to be parallel is that the distance between them is always the same, because they're never going to come together. At no time will they meet each other. Parallel lines never meet, ever. They keep the same distance apart from each other all the time. I don't know what they have, what kind of argument, what kind of quarrel, they just don't want to come together. Perpendicular lines, they do come together, and they come together in a special way. They meet at what we call right angles. And if you stay tuned for the next video, we will look at the types of angles that are created. Different types of angles when lines or line segments, to be more accurate, meet each other, what kind of angles are formed. Perpendicular lines, one is vertical, one is horizontal. They meet at right angles. So wherever you see lines meeting and you see this box drawn here in the corner, that indicates it's a right angle, and a right angle is exactly 90 degrees. A right angle is exactly 90 degrees. So perpendicular lines, so one is vertical, one is horizontal, and they meet each other in the corner here at right angles. So this is a 90-degree angle that I've created with my arms. We could also draw it like this. So one going straight down and the other straight across from it. 4 right angles are created here. 4 different right angles. One here, one here, one here, one here. Because the lines cut each other all the way down, all the way across. Right? So, it's very important to know these basic terms as we progress as scholars of mathematics, as we progress and dig deeper into geometry. Geometry is a fascinating topic. Very fascinating topic. We must know these terms because we're going to come back to them, we're going to refer to them, and we must remember. Right? So a point is a single position in space. We can also call it a dot. We can name the point, giving it a capital letter to indicate the name of that point for reference. Point A, point B. The line segment connects the points, so it has 2 endpoints. The ray has 1 endpoint and continues in the other direction towards infinity. It doesn't matter which way it's turned. 1 endpoint and the other continues towards infinity. The line, technically speaking, should have 2 arrows indicating that it continues towards infinity in both directions. But like I said, when we speak generally in mathematics, we might refer to all of these as lines, and we can get away with it. If we want to be technical though, we must give this definition that a line must have 2 arrows at the end to indicate that it continues in both directions towards infinity, never ends. When 2 line segments meet, they automatically create 2 angles. An interior angle, at least 2. An interior angle or the inside angle, and an exterior angle on the outside. And we say angles are measured in degrees, and we use an instrument called a protractor to measure angles. Types of lines: vertical line straight down, horizontal line straight across, oblique line is inclined, slant, and forms a slope, diagonal. All these words indicate to oblique lines. Parallel lines never meet each other. Always run keeping the same distance apart. It doesn't matter in which position they're inclined, whether straight across, horizontal parallel, vertical parallel, or oblique parallel. They never meet. Perpendicular lines meet at a special position to each other. They meet at right angles, whether creating just one right angle or several, up to 4 right angles. So those are your terms, my scholars. If you have benefited, and I hope you have, just drop a line in the comments to say thank you, miss. I appreciate it. And please share the video so that other students may benefit from the information. If you have not subscribed, do so now so that you can have access to all the videos that come out. Click the bell so you know as soon as a video comes out, so you can stay on top of things, stay sharp as a mathematician. And if you check the catalog and you have not seen a particular video on a topic that you're yearning to learn about, just let me know in the comments and I'll speed things up for you. We're going to cover everything, but I'll speed things up for you so you can get what you need. My scholars, I'll see you in the next video. Take care.